Is there another planet that's very close to Earth, kind of like us, where there could be a civilization?
Yeah, I mean, the closest star system to us, Proxima Centauri, actually has a fairly Earth-like planet around it. We don't know quite how Earth-like it is, but it's called Proxima B.
Astronomers have found clear evidence of what could be an Earth 2.0. This artist rendering shows the rocky planet identified as Proxima B orbiting the Proxima Centauri star.
The enigmatic Proxima B has captured the curiosity of scientists and space enthusiasts alike. Recently, the James Webb Space Telescope delivered its most detailed image of Proxima B yet, sparking questions about the secrets this distant planet holds. Could it support life? What groundbreaking insights has the JWST revealed? Let's explore. By delving into the ancient history of the cosmos spanning billions of years, we can better understand galaxy formation. Building on this capability, the JWST provides an unprecedented view of the universe, allowing us to see farther than ever before. Its state-of-the-art infrared imaging has delivered stunningly unique photographs, offering a new perspective on the cosmos. Astronomers are leveraging the James Webb Space Telescope to study the origins of the universe, star and planet formation, and the atmospheres of exoplanets to assess their potential for life. The telescope's advanced cameras and filters enable scientists to isolate specific wavelengths of light, helping them decode the mysteries of space. The telescope's groundbreaking ability to peer deeper into space and time has already yielded significant findings about the universe's evolution. For instance, astronomers have discovered that massive galaxies contain more matter than previously estimated. Among its many achievements, the JWST recently captured the clearest image of Proxima B to date. This planet, orbiting Proxima Centauri, was first detected in 2013 thanks to evidence of its gravitational tug on its star. Later named Proxima B, the planet orbits Proxima Centauri, the second closest star system to Earth after the Sun. Situated roughly 4 light-years away, our observations of the Alpha Centauri system reveal it as it appeared 4 years ago due to the time it takes light to travel this distance. Proxima B stands out as one of the most Earth-like exoplanets discovered within 25 light-years of our Sun. Though the distance may seem immense, it's remarkably close in astronomical terms. The planet, however, differs significantly from Earth. Its year lasts only 11.2 Earth days, and it is about 30% more massive than our planet. With an orbital radius of just 7.3 million kilometers, less than 5% of the distance between Earth and the Sun, it lies exceptionally close to its parent star. Despite this proximity, Proxima Centauri is a small red dwarf that emits significantly less energy than the Sun. If one were to stand on Proxima B and gaze at its star, Proxima Centauri would appear as a dim, reddish sphere, about 3 times larger than the Sun in our sky. Located within the habitable zone of its star, Proxima B may even possess the conditions necessary for liquid water, a crucial ingredient for life as we know it. As you dream about interstellar travel, bear in mind that Proxima B is far from being an Earth-like haven. One key reason is that it may be tidally locked to its star, meaning one side remains in perpetual daylight while the other is cloaked in constant darkness. Any life forms on the planet would face extreme challenges in such a hostile environment. On the sunlit side, radiation from Proxima Centauri could cause any surface water to evaporate, while on the dark side, temperatures might plunge low enough to freeze water solid. Furthermore, the unique nature of Proxima Centauri, a star with nuclear fusion occurring near its surface, makes it highly turbulent despite its small size, creating an inhospitable environment. Planets like Proxima B, situated within the habitable zone of such stars, are subjected to intense magnetic fields that generate high-energy radiation and particle outbursts. According to recent studies utilizing high-resolution magnetic field imaging, powerful solar flares from the star might eradicate any chance of life. Proxima B receives solar wind radiation nearly 1,000 times greater than what Earth experiences. A dramatic illustration of this was seen in April 2021, when Proxima Centauri unleashed a solar flare 100 times brighter than any previously recorded. Despite the allure of imagining Proxima B as a potentially habitable world, the harsh reality paints a bleak picture. Yet, the idea of alien life continues to fuel human curiosity. In late 2020, the detection of an unusual signal from the Alpha Centauri system sparked a wave of excitement. The signal, transmitted at 982.007 MHz, did not match the typical frequencies associated with Earth-orbiting satellites, leading to speculation. Could this be evidence of intelligent life? While the dream of meeting extraterrestrial beings persists, technological limitations keep us tethered to Earth for now. Travel to Proxima Centauri currently poses a monumental challenge. With present-day technology, reaching Alpha Centauri would take an estimated 6,000 years. However, breakthrough initiatives are exploring innovative solutions to cut this travel time to mere decades. Recent studies suggest potential methods to propel spacecraft closer to the speed of light. The Starshot project, for instance, is investigating the use of powerful lasers to push spacecraft toward Alpha Centauri. By employing adaptive optics and other cutting-edge technologies to mitigate the Earth's atmospheric interference, these lasers, requiring a power output of 100 gigawatts, equivalent to the U.S.'s total electrical consumption, could enable a spacecraft to reach the star system in as little as 22 years. The challenges of interstellar exploration go beyond propulsion. Interstellar debris poses risks to spacecraft, while data transmission back to Earth presents additional hurdles. Even if a spacecraft reaches its destination, it would take about 4 years for signals to arrive due to the vast distances involved. However, once the launch infrastructure is established, sending additional probes could become relatively cost-effective, increasing the chances of exploring star systems like Proxima Centauri in greater detail. Beyond this, the study of exoplanets, planets outside our solar system, has become a focal point of modern astronomy. Since the confirmation of planets orbiting neutron stars in 1992, thousands of exoplanets have been discovered. Among these, numerous Earth-sized planets lie within the habitable zones of their stars, sparking interest in their potential for hosting life. If you've enjoyed this video, don't forget to subscribe. Despite groundbreaking missions like the Kepler Space Observatory and the James Webb Space Telescope, our knowledge of the cosmos remains limited. For those who share our unquenchable curiosity about the universe, who knows what groundbreaking discovery awaits us next?